Good evening. So, ngasi koina rotational motion, system of particles in rotational motion to gudu ni ka. This is chapter 6 hai ta ka. Chapter 6 system of particles and rotational motion. Okay, fine. Now me chat the kino ka thar ko male kana no. All right, fine. Yeah. Okay, so still kino raise message par. Oh, I think that rivera. Okay, audio tadre. Okay, audio tadre duna. Okay, fine. No worries ka. Nay, the class da the whole duni ka main worries ka. So anyway, so akoina sigis da ka akoina kai khangadam no have the quite first center of mass hana khangadam ne, but before that what you should know is motion zi ka ai straight line thamura male ka. Motion have ze. Motion in general, there are two types of motion. Motion makalani lay ko. Translational motion haibama and rotational motion haibama. Akoina hausi powda tamgriba motion je translational ngatane ko rotational tamdri hazik rotational tawrakadoini ko. Adu the rotation jo translation jo animak to su lay ko. Now uneasy ki difference kaino have the translational motion that the change in position takes place. Change in position. We have the object or particle do. Mazi with time magi position change to matamgi matungina. So it will have a certain kedoba magi linear velocity laini ka, and then magi kedoba acceleration laibia little kang de acceleration layers we are later but my position di change to the via table ko. So adudubu translational motion ko ever. Sisina kedo we have the fixed axis. Kedoba fixed axis. Okay, about a fixed axis hierarchy ka. About a fixed axis without any change in position. Position di change to roy basically se ka. Habidi magi particle do magi kedoba center of mass exists to the power the we don't know. But ngasai exist sama fixed to adugi to the adum kind rotation to buneba. Then exist to raise the level fixed exercise. The axis of rotation is stationary hai ta rotation to ge the exist sam change ko aduga translation to ge the exist sang de madi just with reference to some kedoba reference frame of reference ka hai ko. So frame of reference in other words so kai hai have the kuina keno joi origin jo hai ko origin or frame of reference or again so translational motion gi ka kuina some atopa khara kai doni ha matam da with respect to ka adu duma hypet pan gi ka some origin and with respect to some origin with respect to any ko with respect to some origin ka this is very important. Auna origin with respect to some origin have the frame of reference ne ko adu gi respect mazi my position ji change to ne ko adu do translational motion ko auna kuina motion in a straight line or rectilinear motion, then motion in a plane, projectile motion, circular motion, all those motion, adumi the law in translational the change in position takes place. And according to Jikta Makadriba motion rotational motion that about a fixed axis and the axis do not change its position. The axis remains fixed. Aduga sometimes translation ju rotation ju animak yauba motion ju laigani ka. So the mind lay aduna akoina before we go about ka the various physical quantities associated with rotational motion we need to know this ka what is rotational motion have the adudu gine sarna si hana explain to is again tai koiza aduga again physics is all about physical quantities ka. Again, physics is study of nature hydra. And what do you mean by nature? Natural phenomena. So rotation is a natural phenomena. So rotational motion is a natural phenomena, and rotational motion associate tꯧरिबा physical quantities singsi karino and then moi singsi marakta kari relation lei habdo adu khangba matamda sigi chapter je khanga doineba ko rotational motion je मैम यारिबा लक्ष्मी ताब्रा सिंथोई किंगसन एस्टरिस निखिल मैम लोन ताब्रा ताइबको ओके फाइन why voice yam pick na tai kai na ina lei thabera just 1 second ka voice puti dum home like no ina tap na ngang pa man anyway fine yeah so adan so conceptual oina dum chachi ko concept wise systematic oina so quite first no ida center of mass abam le ko center of mass kai no han haige ko center of mass haige kai no matam mass this is some position in space ne ko kedoba aduga masi some representative oiba point or position in space ne yan dai ko such that abdi kedoba okay I'll just write kedoba yam simple oiba definition ko keno toge ko crisp oiba definition am pige center of mass it is a position in space. It is a position in space such that the let's say the entire mass where the entire mass can be assumed to be concentrated hydra such that okay the entire mass maybe assume to be concentrated in case of kedova okay in case of translational motion or rotational motion but again that's not that much necessary center of mass it is a representative position in space representative position and position always position with respect to some origin origin amal laitana position ji for example let us say the earth is a globe manipur da lai na cha so manipur ji kai da lai or for example have the aina lai exactly by the delhi da lai gera manipur da lai gera or wherever I am right now sigi position ta ke ha some reference am change on some reference earth ki in di kai lai ha matam da parallels of latitude lai and then akoina ke do ba longitude and meridians of longitude and aswaina kekeno myam leidana so sigi kaknabam jida ai si point jida lei aina si point jida lei haiji latitude ka longitude ka gi through the khangdoineba adwain tawduna nangna suppose xy plane amda si position ji kaida lei hagadi masi we need kedoba aziki xy plane dugi kedoba origin amada ka leiba origin amako origin du khangaba matungda khoina maji kaidawi ha matamda x axis ta kayam chathoi habidi magi coordinates x y na leiduni dan x axis ta kayam chathoi x and then magi y axis ta kayam chathoi y do dain doroga adana so sigi si kai magi khoina position on ge haragadi si kai ko we have the cc frame of reference haidum id kanoneba frame of reference haiduneba sije origin ga frame of reference ka chap maneba origin habidi frame of reference habineba it's the same thing so aduna center of mass habidi kedoba position neba position habani na kai degi on gadoina habam lakani ba so example oina yengsi example oina let's say kedoba let harga or position of center of mass let's say xcm harga center of mass in one dimension haitare 1d one dimension the center of mass kai leini ya matam da magi different ma'am the position ma'am so let's say different mass layering khalaji auna m1 x1 plus m2 x2 ko plus m3 x3 and so on up to mn xn ko simyam lerani and then total mass haragadi m1 plus m2 plus m3 plus dot 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 plus mn. This is the kedawa formula for center of mass ne ay ko aduga kay gumba 2 dimension haragadi 2 dimension in 2D 2D organa kay hani amatam the RCM haragi ko R is the position vector. So not in a small r synergy in not an issue. So RCM harsi. So RCM or gadi nangi RCM gidi coordinates ani lay ni ba ko aduna kay hani amatam the summation of xi ko mass na hani ige ko summation of kedoba mi xi divided by summation of mi total mass ko and then kaidoni amatam the sigi se sigi pot si kai gamana duino amatam the this should be equal to kaino xcm ne si se ko xcm audagi ycm duna kai gamana ni have the chamana idum summation of mi yi divided by summation of mi within ko. So this is the coordinates ko these are the coordinates so mine lakani yeah ko. So this is very simple. Sumain lakani ko sisina 2D ne aduga kaigumba 3D da column lakshale ko sorry ignore to okay fine aduga 3D da 3 dimension da orgadi zcm habam lani zcm duna summation of mi zi divided by summation of mi and lakani ko. So we'll do one example for this example. Let's say okay, we have the sumaina layer so the massam layer, let's say this is m1 and let's say this is m2 ka. So moini gi center of mass puto u na ko and let's say the distance between them is, let's say this is okay d distance d apart ka. Now find the center of mass hay matam da question is complete oi deva ko sin is center of mass puto have si complete oi bra it's not complete. Why kai complete oi drino have though that is very important ko. Physics is all about logic ko. Physics is an exact science not some abstract philosophy auna adi yamna kasu si the lu ko kem yaw de ko. Now m1 ga m2 ga noi khange ba kai gumba m1 ga m2 ko chap mana ragadi mayai de lai ni je khange ba center of mass and then kai gumba if m1 is greater than m2 m1 m2 then chawbuta ragadi the center of mass will be shifted towards m1 kai the greater mass of the m1 da kai gumba kai doba m2 na m1 de chawbuta ragadi the center of mass will be shifted towards m2 ko kai gumba somna chawbuta som the shift ogini ba center of mass adu chamana ragana exactly may I de laigani ba adu hi concept adu notion du de noi de laire ba but center of mass putho na haireba manabra manadabra su khang de center of mass putho na haireba adi putho haragadi kai doni ha matam da question number what leba with respect to what na position is with respect to what hagadam ne. For example samu makhungdu kyam lapi na question nam hangeba with respect to what samu makhungdu with respect to Kwaketel, with respect to Malom, with respect to Nambol, with respect to Thobal, with respect to Bishnupur, or with respect to Sisipur. Hadi with respect to what have the khang the nine position it's not possible adain to center of mass has position nam never so position to kai the gi on do sir have a question nam la kaneva with respect to the midpoint with respect to the mass 1 or with respect to mass 2 m1 the gi on m1 the kyam lapi na kyam lap to na hangira center of mass to natraga na kedoba m2 the gi kyam lapi no na hangira natraga na m1 m2 gi exactly may I de kyam lapi no na hangira have a question do adu duma hana settle to kan ko center of mass puto kani adu so item ki pini ba question do ko find the center of mass adu katang hanga di question do la le complete oi de question do gyan tai ko sir na ja aduna magi center of mass kai haini amatam let's say xcm ko xcm haibasi the with respect to m1 xcm with respect to m2 xcm CMI ni ko sisa. The CMI bi center of mass ni ko with respect to the kedoba midpoint hai. Midpoint si kaya hai si kasi sisa. With respect to midpoint adum haja lage ko midpoint. Si kai tani do yeng si ko je. Auna akoina ziki summation me am do policy. So distance d la pen kala je ko moini ki ko. Let's say center of mass ko m1 m2 and then distance d la pen kala ji kay lakani simple it's very simple ko m1 with respect to sidagi m1 dagi olagadi m1 into 0 plus m2 into d divided by m1 plus m2 which is equal to kay lakani have the m2 by m1 plus m2 d lani with respect to m2 haran cha mane jikito m1 into minus d plus m2 into 0 divided by m1 plus m2 sir kay gino minus lower is haragadi som side negative side ta chat pagi ne ko habidi som dai olagadi ai ni si x axis ne low ne ko adugini so aduna minus m1 haraga m1 plus m2d sidagi olagadi minus ID left lom da changjala center ma sidai chalaga na right lom chakine ba with respect to the midpoint haragadi kaina have the m1 into haraga ACC khangdabanina m1 into haraga minus d1 haraga aduga plus m2 haraga kaidoba d minus d1 haraga divided by k m1 plus m2 na suma with respect to midpoint in the course na midpoint the yes center of mass to kaidel line have the magi midpoint sidagi ko midpoint dagi lowgadune ko aduna yes midpoint dagi lowdune mayai dagi ko aduna center of mass to aina kaidai haziki distance mayai sidai m1 into kaidoba d by 2 natro oh sorry sir na low is ko last kisi sorry third subus distance mayai dagi low haibani ko aduna mayai di low haibani na kaidoni ha matamda m1 into minus d by 2 plus m2 into plus d by 2 divided by m1 plus m2 tarni ko auna aduragadi kailani ha matamda half to common lower ni puthokrani ko aduga m1 the m2 minus m1 times d divided by m1 plus m2 sita ane center of mass ko with respect to the midpoints gyan taita de sigize ma'am yarbo ma'am yai ko mayai de lower ga disom the chatpani na mass 1 gi distance to minus d by 2 yabra yeah prithvi ras yeah lakshmi sunanda tabra sinthoi nikhil asterisk
oh sorry
Kingston gyan tai ko okay fine so sini center of mass hai se ko auna always have the center of mass has mass nate position ni ko and position in space ni and mass puthoke aragadi origin nam changeba reference nam changeba reference yaudana ko in position takpe yaro with respect to some reference now amatanga ta ke concept ma changba ko center of gravity have concept am lay center of gravity ji khangba mi yaubra ha center of gravity se hana khangakpa mi yaubra Kingston khangbra okay Kingston ji library da lay mane ko cha cheta khumane sinthoi ji library lay re asterisk prithviraj khangbra center of gravity ja Lakshmi Sunanda khangbra center of gravity ja yes no kumak tre oh haziki do d by 2 d se kakpa ya hera kamaina kakpa ya deba d by 2 d ꯀꯛꯄ ꯌꯥꯔꯣꯏ ꯃꯈꯥꯗ m1 plus m2 ꯂꯩꯔꯦ ꯑꯗꯨꯒ ꯁꯤꯒꯤꯁꯤ d ꯁꯤ common ꯂꯧꯊꯣꯛꯈ꯭ꯔꯁꯤꯗꯤ m2 minus m1 ꯂꯩꯔꯦ half ꯂꯩꯁꯤꯗꯤ ꯀꯥꯏꯗ ꯀꯛꯀꯦ ꯍꯥꯏꯅꯣ ꯁꯤꯗꯩꯁꯤꯗ ꯀꯛꯅꯤꯡꯉꯥꯏ ꯀꯩꯝꯁꯨ ꯌꯥꯎꯗꯅ minus d by 2 ꯇꯥꯏꯌꯦ ꯍꯥꯏꯁꯤ ꯀꯩꯅꯣ ꯇꯥꯔꯣꯏꯌꯦ center of mass minus d by 2 ꯇꯥꯔꯣꯏ ꯁꯔꯅ ꯍꯧꯖꯤꯛ ꯇꯧꯔꯤꯗꯣ ꯑꯗꯨꯝ ꯇꯥꯗꯣꯏꯅꯦꯕꯀꯣ still doubt ꯂꯩꯔꯒꯗꯤ ꯍꯪꯉꯣ ꯑꯗꯨꯒ center of gravity ꯁꯦ ꯍꯥꯟꯅꯗꯩ ꯈꯪꯉꯛꯄ ꯃꯤ ꯌꯥꯎꯕ꯭ꯔꯕ ꯂꯛꯁꯃꯤ ꯈꯪꯕ꯭ꯔꯥ ꯍꯥꯟꯅꯗꯒꯤ center of gravity ꯁꯦ ꯈꯪꯉꯦ ꯍꯥꯏꯔꯣ ꯈꯪꯗꯦ ꯍꯥꯏꯔꯣ ꯈꯪꯗꯦꯕꯀꯣ ꯑꯇꯩꯗꯤ ꯈꯪꯕ ꯃꯤ ꯌꯥꯎꯕ꯭ꯔꯕ ꯁꯨꯅꯟꯗꯥ ꯈꯪꯕ꯭ꯔꯣ
object amagi within the labor point oduba the sida gravity effects se equally phangro
ꯑꯗꯨ ꯑꯣꯏꯔꯒꯗꯤ center of mass ꯀꯃꯥꯏꯅ ꯇꯧꯔꯒ ꯍꯥꯏꯗꯤ center of gravity ꯒ center of mass ꯒꯁꯤ ꯀꯃꯥꯏꯅ ꯈꯦꯠꯅꯩꯅꯣꯕ ꯀꯩꯗꯧꯕꯒꯤ center of gravity ꯍꯥꯏꯕ ꯑꯃ ꯂꯩꯔꯤꯅꯣꯕ center of mass ꯍꯥꯏꯗꯤ ꯍꯥꯏꯗꯤ ꯀꯩꯗꯧꯏ we already have center of mass ꯀꯣ ꯑꯗꯣ center of mass ꯂꯩ ꯂꯩꯅ center of gravity ꯂꯩꯁꯤ ꯀꯩꯒꯤꯅꯣꯕ what is the difference center of mass ꯒ center of gravity ꯒ ꯀꯩ ꯈꯦꯠꯅꯩ ꯈꯪꯕ꯭ꯔꯕ
sir hojik haifet tining jange do haifet fazana haibade ngamdre
ꯐꯖꯅ ꯍꯥꯏꯕꯗꯤ ꯉꯝꯗ꯭ꯔꯦꯕꯀꯣ ꯑꯇꯣꯞꯄꯗꯤ ꯑꯇꯣꯞꯄ ꯃꯤ ꯀꯩꯅꯣ ꯇꯧꯕ ꯍꯧꯖꯤꯛ ꯀ꯭ꯂꯥꯁ ꯌꯥꯎꯔꯤꯗ ꯈꯪꯕ ꯃꯤ ꯌꯥꯎꯕ꯭ꯔꯥ center of gravity ꯇ꯭ꯔꯥꯏ ꯇꯧꯒꯦꯔꯥ ꯁꯔꯅ ꯃꯤꯡ ꯂꯣꯏ ꯄꯟꯗ꯭ꯔꯒꯁꯨ ꯅꯣꯏ ꯆꯦꯠꯇ ꯏꯔꯁꯨ ꯌꯥꯏꯕꯀꯣ center of gravity ꯈꯪꯕ ꯃꯤ ꯌꯥꯎꯕ꯭ꯔꯣ ꯑꯇꯩ ꯈꯨꯝꯃꯛꯇ꯭ꯔꯦ ꯀꯤꯡꯁꯟ ꯑꯦꯁꯇꯔꯤꯁ ꯅꯤꯈꯤꯜ ꯇꯥꯕ꯭ꯔꯥ ꯁꯤꯟꯊꯣꯏ ꯑꯗꯨꯝ ꯀꯩꯅꯣꯗꯩ ꯈꯨꯝꯃꯁꯨ ꯌꯥꯏꯕꯀꯣ ꯅꯣꯏ ꯆꯦꯠꯇꯩ ꯈꯨꯝꯃꯁꯨ ꯌꯥꯏ ꯑꯣꯀꯦ ꯅꯣꯏ ꯀꯩꯗꯧꯕ ꯈꯪꯗ꯭ꯔꯕ ꯇꯧꯔꯤꯁꯦ ꯑꯣꯀꯦ ꯁꯦꯟꯇꯔ ꯌꯦꯡꯉꯨꯀꯣ ꯁꯔ ꯍꯥꯏꯔꯛꯀꯦ ꯃꯨꯟꯅ ꯇꯥꯔꯣ center of gravity
sir
ꯀꯩ ꯍꯥꯏꯕ
center of mass tadi mass to all the masses to amok concentrate tawraga lay habado to within sir aduga center of gravity tadi art ki gravity se sin ek tawa point to aduga sometimes center of mass ka center of gravity se manai haina lawsu lay aduga adum chumbra haibadi chumda
ꯅꯠꯇꯦ ꯑꯗꯨꯝ ꯃꯥꯟꯅꯕ꯭ꯔꯥ ꯍꯥꯏꯔꯗꯤ ꯃꯥꯟꯅꯗꯦꯕꯀꯣ ꯑꯣꯀꯦ ꯐꯥꯏꯟ
ꯁꯤꯐꯥꯎꯗꯤ ꯅꯤꯡꯁꯤꯡꯉꯦ ꯁꯔ
ꯁꯤꯐꯥꯎꯗꯤ ꯅꯤꯡꯁꯤꯡꯉꯦꯕꯀꯣ alright fine now ꯁꯔ ꯍꯥꯏꯔꯒꯦꯀꯣ ꯇꯥꯔꯣ mass ꯈꯨꯗꯤꯡꯃꯛꯁꯤ ꯀꯩꯗꯧꯏ ꯍꯥꯏꯕ mass ꯄꯨ ꯂꯩꯔꯗꯤ gravitational force ꯂꯩꯕꯀꯣ ꯁꯔꯅ first classꯇ ꯅꯣꯏꯒꯤ ꯍꯧꯖꯤꯛ ꯍꯧꯖꯤꯛ ꯇꯧꯔꯤꯕ ꯑꯩꯈꯣꯏꯒꯤ lecture series sigi first class da ko day 1 da ina force mari gi matang da hai gi bane gravitational force electromagnetic force strong nuclear force weak nuclear force na ko so mass polarity gravitational force lay ko that's another thing now center of mass has nothing to do with force ka mari sungai nei na deba center of mass gan dai ko ja but center of gravity the force ka mari lai nei gravitational force ka mari lai nei and gravitational force si karam id again gravitational force conservative force ne adu mai field lay gravitational field lay ko auna kaido wi ha matam da sigi se again center of mass su center of gravity su kaido ni ha matam da balancing point nga ta ne ko both are balancing point or balance to be a point ha ja ko no we can say BLANCING balancing point with respect to kaidoba gravitational field ko that's right noi kanano ma ire ko I don't know who kana ire non noi mi hum lai min na kana ni no di khangre gravitational field ko so aduna di kaino ha matam da let's say sumaina road am lai ko so I have a rod and it has uniform mass per unit length my mass per unit length c uniform mo ko C rod sigi center of mass kai leni always may I the leni si center of this body the the same sigi rod se aina when it is subjected to non-uniform gravitational field is somna kandana taptai strong wherever yanda guys gravitational field is somna kandana taptai strong wherever and somna kandana amtina weak wherever adu ergadi kaidoni have the center of gravity is swai the shift oneba this will be the kaidoba center of gravity my center of mass is sidadum lay because center of mass day but kaidoni have the due to the non-uniform gravitational field the center of gravity will be shifted gyan tabra ta tabra sarnaija auna field kaya tai have ko ana sigi concept si kaidowi have the kitang misconception the chatpagi yam tuina thengnei sarna center of gravity ga center of mass ga jinoi gi sarna even no recommend to riba no is ki 37 years ki copy YQ ki solution do MTG gi moi gi su si concept se soi bane ko mo sem dok ti je kai no hang de adai to na he soi ba thengnei center of mass ka center of gravity ga two different concepts ni manade center of gravity di kai no hai matam da in response to gravitational field oigadam neba center of gravity in response to gravitational field center of mass it has nothing to do with gravitational field se kai human layam da ta ga zu magi massing do adu du gi just magi balancing point ha ga or representative point neba and center of gravity the representative point natte ma the balancing point neba khenai conceptual conception manade bani kyan ta braja center of mass na representative point center of gravity na balancing point but again sometimes center of mass balancing point when the field is uniform but field okay you make non uniform raba center of gravity shift to gini center of mass tagi kai no ma field strong we na kan dum shift of level center of gravity kai no som na kan ching daram ni na ma balance to gari som da sat kiroi draw som da na kitang less oi na gravitational field do kyan dai ko ja yan ta bang amram yam loni mak
ngam sir
ami ko so da mathan ko mai kai na atai loin ta bro Lakshmi ta bro Prithviraj ta ho bro
ta ho
ta ho ko okay fine atai di khang re kana kana no ai di noi chetal pun ne yomi ra king sen tai hai ko okay fine so adune CN is kenai so kenai is the base to question je hang pe ai ko aduna adu gi do ma check lo exam da hang pe ko okay so let's move on now center of mass ki question karo ho chiko kam lai yo am tin live question hoi deni ko so auna noi gi da 2020 ki matung ki question le ga di sir da photo ka patharo ko sir am solve to na no mang sai de pat tat laga dum join to raga kan to le to ming ju tha de okay fine so two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length blah blah the center of mass of the system from the with respect to or from the 5 kg mass hydrosa is nearly at a distance of an center of mass from where from what with respect to what and have a question jima answer p the center of mass puthokpada yaro ngamoy ko so two particles of mass kain of 5 kg ibam le okay so sida mass am le record then 10 kg have so this is 5 and let's say this is 10 respectively test of this is 1 meter lap nahi munis 1 meter apart yare ko do ergadi the center of mass of the system with respect to 5 kg so see 5 kg sidagi center of mass 2 km lapi na oh this is so simple the center of mass xcm is equal to our 5 kg 5 into 0 then 10 into 1 tarba so again I'll just write completely 10 in 5 into 0 plus 10 into minus 1 divided by 5 plus 10 this is minus 10 by 15 the 5 to 10 5 3 15 the minus 0.67 so this is meter so which is equal to minus 67 centimeter ngaiko minus nati plus ni ko plus ni kai gino di aina 10 lom dei low beta da khalle je minus nati plus oi dini ko plus oi dini kai gino di cc 5 kg mass dagi low bani na right positive direction da challe ba ko aduna 10 into 1 kai guma 10 kg de lom bata ga di 10 into 0 and 5 into minus 1 haram dini ba ko ana si 67 obviously yone chumdre yone 1 meter ni na this is 0.5 meter ne se 0.5 meter ne ba auna 0.5 meter da gi right side ta lei roidra haidi khara lumba lom da changthal roidra center mass ta lumba hai gera mass ya lom da changthal roidra ba changjan ni ko auna 0.67 kai yuma with respect to 10 kg haram men khala je ba adudi kai wani 10 into 0 natra 5 into minus 1 plus 10 into 0 by 15 da roidra 5 plus 10 is 15 Audi kai tane the minus 5 by 15 ne which is equal to minus 1 by 3 ne which is equal to minus 0.33 ana sigi sidai minus 0.33 hairagati sorry sidagi 10 kg de olam 10 kg de minus 0.33 adi swai dum lai roidra auna center of mass sida dum lai ne ba this will be the center of mass with respect to 5 kg mass 67 centimeter chatlo hai ni ba sidagi 50 and then another 17 nang chaladi 67 now, with respect to 10 kg, I have the left from the minus 0.33 as you can 33 centimeter. Some the 33 centimeter left from the low minus side 30 centimeter left 5 now. So mine chat laga see the lakani. I point to the chapman and nibuka. So kadum they own have the with respect to the midpoint, with respect to 5 kg, with respect to 10 kg, and then perspectives say home to not pair, or with respect to some kedova frame of reference, the own position vector, ma'am, to adusi yaiva, kam kai debaka. So, gyan tao bra jikita, ma'am no nimak.
Tahoe, sir.
Tao sir.
Okay, great.
Tahoe, sir.
Great. Noi question khang da ba yaw brem ko atai 2022 gi matung da hang ga dia. Yaw ga di hang sir da ko. Now question number 2, 3 masses are placed on the x-axis, 300 grams, blah 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 blah. The distance from center of mass. Sigi question ni no shu hot ta bidam tangam breng ji ko. Haidi keno yaw da bidai tare. Pen pai da bida. Adum question ji yenga kumbangam breng si questions. So the distance of the center of mass from the origin have origin dagi aduridi kaino have the 300 into 0 masan lai jagrani kaino 300 into 0 aija kaino the 300 grams ji kai de laiba origin da laiba at origin hydrosa 300 gram at origin and 300 into 0 500 into 40 54 di kaino 80 8 later 4 into 7 di kaino 74 di kaino 28 natra. So 28 plus 40 is 68 so 68 divided by 5 plus 3 8 8 12 68 divided by 12 so how do you get that 12 there 4 no 4 3 12 4 1 4 5 6 7 4 28 17 by 3 tie 17 by 3 diffraction tie you know I do swear 7 4 28 came kaide and then 5 4 20 5 4 20 ne I did 48 I have a 48 by 12 I have a the 12 4 48 so the correct answer is 40 centimeter 40 centimeter tabro ma'am I see 48 by 12 or this one holam mariko direct 40 harman I know command 68 kalwin 40 tabra kanam ko magtre tabro
Tahoe, sir.
kaino kanana d man laje d tar moida d 18 ni gano d comment ta d tabra ne question book kya hai si chapter dum saw di saw ka question number 1 di ora ma jikido kaya no question number 2 na tra a ta is di se ka okay so question number 2a 40 ta da se aduni so ho ta bi da hang am head question number 3 is this and this the center of mass of the system has a position vector of c simga ta usi kaino le mass vector ki form da lai bani na ka chis yam lai da ko yam tin lai two bodies of mass blah 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 have position vector. This the center of mass of the system has a position vector. The position vector in a pyramid origin do or frame of reference so fix oizareba ko origin da gi moji c gi position vector lay haibnina magi center of mass ti yam tin lai c gi ko ana noina kamaina magi kedo center of mass ki vector ji puthokani hai matam da ax let's say rcm vector je ko let's say rcm vector is equal to 1 into 1 can I guys 1 say akoina ke do we have the magi si akoina kai leini ha matam da ko let's say so I like the name ko m1 x1 plus m2 x2 ko divided by m1 plus m2 I kept late plus m1 y1 plus m2 y2 बोलो टाइम तो लगेगा 9:30 तक का है हाँ ठीक है डोंट वेट m1 plus m2 z cap plus m1 z1 plus m2 z2 divided by m1 plus m2 k cap सुमाइले इदुनी बको सीसी सरन ngasai tawgib du chap manai ko gyan tabra mya tai ko adu si nga haro 1 into 1 plus 3 into minus 3 divided by 1 plus 3 so si di kai tare minus 9 the minus 9 the 1 kai do di kai no minus 8 by 4 the minus 2 yaw bu sikam kam no si jim yaw re ko auna zik makata na solve to the yar kai no option ji the koi ne yeng aga negate to ge to ni adubu option G we have two different options auna makha ang to ji makha ji kai no have the 1 into 2 plus 3 into minus 2 divided by 1 plus 3 3 into minus 2 the minus 6 ka 2 ga di minus 4 of the minus 1 tarni on minus 2 I cap minus j cap tarni so minus j cap ti si yaudre ko on si lalani audi kai tarni e dum tarni asi lan thokreba atai jibudi dum hobuga lan grena ko so sumain to dun noi pekha da si mu hot kanoba si hot pe mathau ta deba sir budi ji hol lage ko adur jun noi pekha da di hot kanoba matam pamuyeba 1 into 1 plus 3 into 1 divided by 1 plus 3 4 by 41 and plus k ke to sim tar ba tare ko so sumai hot ke dune ba center ma se am lai dra duna lai ko gyan ta over me am
oh dai sir
I got it be rest okay so here the question okay question number 4 consider having if the parameter most towards the center ma trade by what is again C की question जी तीनों ही ngam gadra set to ra hero 4 je ngodu hero noi ngam ni har di kandu ni ngam moi har di san to din hero 4 je ngam ni ngam hero
What's this, sir?
what se ba okay fine Consider a system of two particles having mass m1 and m2. The particle of m1 is pushed towards the center of mass of the particles to a distance d. All right, so c layer and then c layer में बुका. Now c के दो ये मतलब the distance d is move to रे बुका. मसाई की हाना ले हम जगह सी देगी. Distance d move to रे. By what distance would be particle of mass m2 so cam distance cam move to do ना हमने center of mass to suppose let's say center of mass the layer kala jeba adu center of mass da dum len ga mass khadi move to the yar mass na kaya move to do na हमने so c की distance की ना da okay very simple ko. Let's say they are at a distance kedoba x apart. Adudi mo isi kay na x minus d tarni. Nati sorry x minus d nate. Let's say this is m1. Let's say this is m2. Auna aduragadi sigi kedoba central mass di ling wave. Aina hadi when I central mass so as to keep the central mass at the original position. Central mass is two different scenario dagi putokadune but ling damni central mass chap manani gyan tai ta de tai ko auna kay no amatam the xcm is equal to xcm dash central mass ani ling deba aham by central mass sidi kay no amatam da m1 let's say kai degi on zige no haro kai de on zige mass 1 de on 0 mass 2 de on 0 mayai de on 0 mayai de di haro no mass 1 or mass 2 apam ba haro mass 1 lower ge ko
M1 lagi.
m1 degi okay fine so m1 degi lower ge di m1 into 0 plus m2 into x divided by m1 plus m2 okay fine moine ga sigi distance piram rasine yeng piram debo ko second dagi olagadi kaino amatam da second dagi olagadi hazik aina centro masi on matam da sidagi si new position de on be adi ngasai gi position du de dum on du neba m1 le position du dagi kaino di centro masi position neba position ji karam kanda khong ni have nangi reference point to au de ola kan khong ni for example samu ma khong ji kwa kaitil de kyam lapi hai baga samu ma khong ji khongwan de kyam lapi hai baga mana roiba samu ma khong gi samu ma khong dum oidune ba adain to centro masi dum oidune ba but maji original di ngasai gi mas 1 le emba jaga dagi on baga hazik mas 1 ji ka shift tawgram ni na haji jikti centro masi khongoi ba aduna position change la ne position change la lo ge di ngasai gi de mon du ne ba ko auna ngasai gi distance de dum mon ni so ngasai gi distance di amuka akoina kari ngasai distance su si tarni na m1 into 0 tarni so anova central mass hai bane ko si shifter on ni si shifter re natra aduna central mass ti hongoi dune ko sarna di hai gi do same reference point ni with respect to m1 mazi m1 ji kem lap kre have the m1 into d kaino di sigi position dagi mass 1 ji d position shift tawgre ba ko aduga m2 zina m2 ji khara di shift tawrani so m2 ji kya shift tawrtino have the khang de adu du ne putok tu ji gyan dai ga ja so okay fine let's say m2c kai no have the d ga comment or ga related oini have the mo yeng se ba ko na sai gi do ke da wa sai ji x le ba ko du ne x dash low zero but mo gi si d ga keno ga da ga ta thama me ko du ne m2 m1 sina d la pe m2 sina yes m2 sina kyam lap kani ha matam dane ko mo gi original ji x ni hojikna d sangsal le d sangsal ko matam da maji sidaina sipogi distance e kya no khangde si distance ne mo puto ha na tra so as to keep the center of mass no c puto ha na te c ji puto ha ne ko but c jo mo khangde ba ina gyan dai ga ja c gi distance e khangde ba m2 ji kyam sangsal ka doino haibani but again tasing na mai centro mass puto ke si khangadam ne ko ai si di khangbra habda khangde ko on khangda po che ani sure adu di comment puto kani have potumal leire so cg kuina kai pan be yai habda m1 game to we han original distance x or mane ko aduga new distance new distance let's say in its let's say this is some x some d dash and lower 0 m2 into d dash adurgadi kai oini ha matam da yes ka m2 into ha na ka let's say ma z aina d dash ko taragadi my position ji kai oini have the x minus d dash taroidra tani taroi
Tani.
ka gyan tabra tade
Tai.
yung ko CC D dash never. I D dash kang deva. Adu CC obviously x minus D dash am tare. Yare ko. Adu gadi aina puto ko this D dash never. Au na si equation ni ji mana baina m1 plus m2 m1 plus m2 loin cancel sakre ko. Adu na kai tarni matamda m2x one second ko. M2x is equal to m1d plus m2x minus m2d dash. So m2x cancel sakraba. Okay, no me to is one second ko. Answer budi tare. Aduna kai tare sidi. It implies d dash is equal to m1 by m2d. Tarban sir. m1 by m2d tabram. Tiyo.
Oh, Taisha.
Taiko. So ज्ञान ताहुब्रा सर सोल्व तो इसे ज्ञान ताहुदब स्टेप यावब्रा
Tayo, sir.
Sir, diagram to have you in diagram to get hold.
Okay, diagram kitang tahudre ba. Okay, don't worry. Kay na season le na. Okay, so na ka da ba ka. Okay, fine. Tanga ha ke ka. Kay do we have the moini zi hana kay do m1 m2 layer me do moini ki distance let's say that is small x in a representer ge ba ka. Aduga hazik kay do we have the kay yuma mass 1 zi d distance angjalak pa taragadi angjalak kadoine ba d distance angjalak pa taragadi mass 2 zi kayam angjalak kadoine have never so that the center of mass remains the same have never auna according to the formula for center of mass ki formula matung in the magi c kaino have the position do m1 into 0 plus m2 into x divided by m1 plus m2 low revoko. Now, adugi with respect to this same position, m1 is the lape d distance m1 into d la never. This is m1 never, and this is m2 never. And m1 into d taura never ko. Aduga c d ds matate e gave ko. Aduga matangi mass 2 is m2 is khara di changjalak to be yaro center mass shift over m2 into d dash. High get id aduga m2 d dash changjalak putar gadi. Sidagi on but the cam lapani have the total x to the d dash kaidoidra magi distance to ganta the bra habdi mazi d dash sanjan grabanina magi distance from this origin this line sidum like neva central mass with respect to this line never kun putujing side gi ahamba the d came the link the nina central mass with respect to this position g m1 into 0 m2 into x divided by m1 plus m2 with the laser. Second scenario, the m1 into d, the d lape, and m2 into r c opposite, have the x minus d dash, Go. So this dore, or the she kanda d dash is sitar. Yan tahu dabra. Okay, yeah, Nico. Atay di Lakshmi yan tahu bra.
Tahu sir.
Atay library kangu sintoy of the gi Kingshan asterisk. Nikhil Gyanta bro, library kangbu. Chetai Rajai. Okay, okay, fine, great. Let's move on. Question pazay, question number 5 today. Question number 5 is parong ang badriang. It's so simple. Parang 5 to.
D with
B male baka. Okay. Just a second. Question number 5 is the high second. 3 identical metal balls, each of radius r, are placed touching each other on a horizontal surface such that an equilateral triangle is formed. When centers of 3 balls are joined, the center of mass of the system is located at the line joining center of any 2 balls, center of one of the balls, horizontal surface, and point of intersection of the medians. So point of intersection of the medians tarni D tarni ka. Option number D. Sisi the gyan tadaba mi yaw bra. option number D ke dawai ta doine je Lakshmi option number D ji kyan tabra
Tayo, sir.
tayo ko atay di tabra
Tayo, sir.
Prithviraj tayo ko okay atay library kang budi kumar anyway fine no worries now the center of mass of system of particles does not depend on position of the particle, relative distance between particle, masses of the particle, and forces acting on the particle. So, kay tadi no? Question number 6 is center of mass kay depend the does not have any code, does not depend on what? Option number A, B, C, D. Kayo ini center of mass does not depend on kaya di no? Option number A, B, C, D.
Sir, D oitawa nga.
Very good. D ini buka. That's nice. Chome. Kay no amatam sir na jikta high ibda ngai buka. Center of mass is position ID frame of reference natra origin do adu depend center of mass to any position ID kaino depend again adu center of mass ki my formula the position yawina position of the particle yeah aduna relative distance depend masses to force depend de adu kaigum center of gravity kaino to bata adi gravity rom the scheme lang number ne am call to as Delhi की सर की नंबर Delhi द केनो तो मैं Delhi द बहुत हदरा में चाहिए घर का Delhi लेंगे जा यम कुछ ले में Delhi द अदुना बहुत की करना मोई केनो तो रही कॉल जी नंबर सिले तो रही नंबर फने हम ब्लॉक तो रम ने तो अदम तो रही anyway का so सीसे में यार नहीं का now motion of center of mass इन की दे कखरगुम तो दाय motion of center of mass याव बरे उन्हें की द
Yaude, sir.
याव दे बका other sir happy talk me hi go the center of mass ya me motion of center of mass the based of question adum lak pagi chance lay hai di specifically the ek a na mo ne kaisu pan manate ko auna sir talk kom hai ge ngasai aina explain to the center of mass ji kai no na explain to ina adwain to motion of center of mass kai no na happy explain to ge talk kom ko again motion of center of mass kahini kitang strange so ini ko ta bada ado again this is true right. For example, there is a boat, and then, okay, let's say this is person A, and then this is, let's say, okay, fine, there is another person B, so person B is person B, okay, fine. Now, this is person A, and let's say this is person B. Adu di center of mass kai de laini have the sida laini have center of mass ko. Suppose sida lai ren khala je. Yare ko. Now let us say aina kai gumba sigi kai do ba kitang change to ge ba ko. Kadom no change to sige have the let's say this person is in som the chat len khala je. My keno le hore ni. Masa kai ka le hore to line yung yaran itu kitang chakalam ju padam ne ko anyway si person is in shift or ga sida pure ko kayuma sida pu batar ga di kaidora kani khangra sige ne person is in som the shift or en khala jeba audi centro ma si di leng ba yadaw ni na ne kaidora kani habda sumaina centro mass boat si asom site ne han gini ko boat sa halaga magi center of mass kai de lakani have the soy de lakani ganda right and then have the kind of the boat system side to move to gini aduga kari gumba aina sigi potsi let's say boat si assume the move to han lagi handa muna ka kai gumba if this boat the persons are position here have the person ke doba ka sikitang lapthon let's say som do in a move to ren khala jeba ko this is person A on magi manak the move to ren khala si then adu ibata agadi center of mass kai the shift or kani have the 1 second ka center of mass no pass out sumain leini aduga whole kedawi ha matam the whole center of mass se always straight line si ma pas dum leini gyan dai ko haining is not sarna haining is kaino ha matam da body amagi ko center of mass have se si kari na hongan bangam de have da akoina manung id center of mass mo hongan ba matam da ne external force da ka le external force na khatang khak center of mass hongan bangam me id body du manung da yaw force ko internal forces sing za sina center of mass hong bangam de aduna sigi both and then two-person system. So this system consists of two persons and one boat. Si the C person jina si the gina mana A jina B gi towards the sat pamatam da moini som let me na matam da ne. Centro mass se obviously moini lom the lakshala kaneva but centro mass is the position never. Ana position do di hong bea dam boat chene leng kaneva. Boat che aduna asom the push tau gineva. Kayumba B jina person ye gi mana the lakpata aga di boat che asom chakaneva. Duga centro mass ti hanai mapadu da dum laini boat che leng kaneva. Sir nining is gyan tabra.
Yes, sir.
Taiko. Noi si thing na bayar ba. Sir gi keno lay bane ko. Ay dita saying na khandi kalu da bane ko. Sir na 2019 da ize ima adi ke ne. Loktak ta hi hon ba yam highway wadi na te but bit amada hay tar highway hay to to hi ho lega. Hi sum ho le sir gi friend ani na maning da tong e do ay na hi ho lega. Sum ho lega hidang bam hay gadra. Ama moy gi swa nga sar ga lay bido. Adu ma pa ji yorok ko kan ji da ina soi bai ta ju ko. Hi wa kan ji kan udra. My now hay gadra ho na bido. Adu poto paina nga sai hidang bam gi nga sai gi wa du sai isa ji lam bai ta. Isa ji lam da di ke do ya. Ai body ji na asom the shift torm ni na. Boat to ke do wi boat to maning han gi ban. Boat to maning hala sar je lokta ta tasal le ko. Adum adwai du da dum yam lu go di na te ko sam lep muktang ni yam lu ba na te bai hidang bam yora ne ha je ne tasali do mai de ga ta ba ka wa de ni ko iroi dra ga di anyway so sir na haning is kai na da aina isa ji hidang bam yore na ina chakhat ga lam bai da isa so to ben tor ko aduna ai gi mass ina manung da shift tor ni na central mass leng be ya da ni na bot to maning han gi ban adu ai de sing da tasal le ko sir na haning is kyan ta bra
Yes, sir.
Taiko. Aduna, haining iba po si last kay na the motion of center of mass ki motion z it can happen only have the kedawa if there is an external force. If there are no external force, internal forces khatang na di center of mass ki hong sungam mo ba. Center of mass to hanay position do dam lai ni ba. Sir kaino hana boat ki mayay do le mga si hong ay si boat ki mayay do position na te ba. Center of mass is position in space. Adugi jaga the boat ki mayai du oiramwan hajikti boat ki mayai du oidreba but centro mass adum oiri was gi jaga du boat tu gi mayai du leramba wani hajikti boat tu gi mapa ma leire adu dun centro mass oidene adu asom chalaga na mapa to pam oire adu dun centro mass adu position du di hong de ko boat to lengja we wani gyan dai ta de tai ko hajiki jaga do in space to leave jaga so hong until unless external force apply to juge internal forces na centro mass hongan mangam deba yare ko myam gyan tai ko tai so it's a very nice question. For example, question number 7, two persons of masses 55 kg and 65 kg respectively are at the opposite ends of a boat. The length of the boat is 3 meters and weighs 100 kg. The 55 kg man walks up to the 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts by. Kyam shift or kanayudi? Khangbra? Kanam ko maktre. Option number D, Kingston ka. D hai series. D hai ra. Nate D di mamang ki question lugi male. C gi se kai mali hai ra. 7 gi se. Kai yino kanam to respond to okti ja. Hainero. Kai yino still no response. Question number 7 2012 की question जिसी की answer जी कई हुई दिनों है रो सुनंदा लक्ष्मी किंगशन निखिल सिंथोई पृथ्वीराज कहीं ना नाम को मंत्री है सिंथोई सी okay fine C kenoni ko sigi recorded session ina duain sir na jan hanga ga noi khum da video ko to bi leib do du zoom phajade ba ko na question je keno to ba noi phana respond to ro respond to tragadi keno to de ba phajade ba ko du ni sir na aduna sir na hanjan noi gi ming oina kauthok ta bi da noi na dum na sana khumjara ku duna aduna hena phajai ba ko du anyway fine. So C is equal to C the correct answer is option number C, which is 0. Then the mass came to shift over. The person sing the move to the internal force, the internal displacement, external force number more came cannot overlay the center mass to shift over. Lakshmi, Prithivira, Sunanda, Gyan Tabra.
Yes, sir.
Okay, fine. Question number 8, question number 9. Two particles which are initially at rest move towards each other under the action of the internal attraction. If the speeds are this and this at any instant, then the speed of central mass of the system will be again. Moinizi rest move toward each other under the action of the internal attraction. If the speeds are v and 2v at any instant, then the speed of central mass is
0.
0. Very good. Central mass 1. A man of 50 kg mass is standing in a gravity-free space at a height of 10 meters above the floor. He throws a stone of 0.5 kg mass downwards with a speed of 2 meters per second. When the stone reaches the floor, the distance of the man above the floor will be. Sidi putok yani sisi ngamgadra ngamoidra. Hairo. Ngamgadra ngamoidra hairo. Keva ngamoy hairo. Okay, settle again. Yam live question ko. So let's do it.
Sir, conservation of momentum bandero.
Conservation of momentum pangadra. I would yings ko. Conservation of momentum pan be the right yings. A man of 50 kg mass is standing at a height of 10 meters above the floor. Gravity he throws a stone of 0.5 kg mass downwards with a speed of 2 meters per second. When the stone reaches the floor, the distance of the man above the floor will be. The floor I am later saying na have the car. The main am later and mana kedoba stone pyramid. And I got that. As you see, stone zimana zik. We have the lung mana sige stones. Lung. Langaga we have the let's say this is 10 meter distance lap have 10 meter distance lap na you got nis. And hazik we have the amazi see ogre. See ma pass ogre ka. The distance of the man above the floor will be. Adiding aside distance of the man do cam lap can have near floor de mazukra lap torani buka. Yam di lap toroi kain kitanga lap torani kay di. I'm gonna 50 kg ni amana 0.5 kg ni buka. Now this is kaina yam simple over center of mass ki kuigi kaino do tawgodini buka. Amna yung sida CC equina kay don't have the center of mass ti hong wave. Sige sida ko kay external force yaw de internal ne mana lang may na masukra handora ne auna xcm nga sagi do xcm is equal to x dash xcm dash right there. Now what is XCM? XCM is kaidagi lawsige main du de lawsira. Main du de lower gadi kai torne 50 into 0 plus ngasai di kedoi ngasai di sida dum le ni ko intro mas. Okay. So anyway, so mine ko hot rasu yare du gadi yam line hot pe yare ka distance to. So my whole rege ko pang note pa ko ne. Audi kai du ni am tam da 50 into minus x ka plus distance of the man above the floor have a ka 50 into minus x line plus hierarchy kai 0.5 into hierarchy c distance is puthok se ba ko divided by 50.5 never. Now c distance c kamain puthokani hai matam da my distance 10 meter na tra. He throws a stone of 0.5 kg mass downwards with a speed of 10 meter per second. I have got okay, fine. So 10 meter per second lang ba. So 0.5. Okay. Ngai ko dur gadi magi kedoba zik central mass. Okay, the distance of the man above the floor. Floor do they mazi cam lap thui. Sidagi has it, let's say C position sidai mazi cam lap thui have one ko. Okay, fine. Dur gadi question C. M2 V2 is equal to 0. M1 V1 plus M2 V2 is equal to 0 hierarchy koina adudai puthokpadi yabra. I have the V1 di khange ko audagi kedoba sida ngasai the problem am lai ko multiple id multi perspective from the khanjeba wa kanje ko ana ngasai M1 V1 plus M2 V2 is equal to 0 kai gino di U1 ga U2 ga 0 ni na ko ana sidagi moina B2 di pyramid sida B1 puthokpa yarni ko aduga sidagi aina time du puthokpa yarni time du na adudai puthosu yadi ai aduzu yadi ai ko sisu yadi ai khangbra sisa sisi yai ji kai gino amatam da nang V2 ji puthokpa yam lai adi V2 di 2 ni dana ko auna adudi B1 khangani now B1 ji ngasai gi time du dai puthosu yani ba gyan tabra for example si han tawge ko aduga si nataba atopa way de ju puthokpa yani have the kind of the 50 into V1 plus 0.5 ka momentum do momentum z kind of the opposite direction in a the minus la ani momentum z ka minus net momentum z 0.5 into let's say 2 meter per second should be equal to 0 now yare ko adu regadi kind of the V1c 0.5 into 2 the 1 ka so 1 is some pugro auna 1 by 50 tare gyan dai guys so now adu ibita regadi hazike dawni ya matamda aina velocity z 1 by 50 fang now ngasai time du yeng se ba ko mazi 10 meter chat lewa auna t is equal to kind of the distance by speed never natra time the distance by speed natra auna distance kind of the 10 meter and speed na kind of 2 adu di 5 seconds jangewa adu di ngasai gi magi distance se ko let's say this is S2 or S1 whatever 15 to ko so this is let's say S2 adu di S1 puto ke agadi kaino B1 into T1 and T1 and T2 sa manai auna B1 di kaino B1 di 1 by 50 into 5 which is equal to 1 by 10 which is equal to 0.1 meter right there adu di ngasai gi du kaino already 10 meter la paimna 10.1 meter is the right answer gyan taw bro si se
Tahu sir.
Tahu je.
tahu ko Prithviraj Lakshmi tahu res Sunanda tahu bra
tahu sir.
tahu ko sumaina holazu yai ko sumaina holazu yai adu nattaba atopa way da hot ninga gana kuina kedo we have the central mass ki concept palaga ko central mass ki hong oi dana ko aduna ai atopa way am the hot ki ko sige same question. See, I'll just repeat once again. Prithvi rasna conservation of momentum palakkudu dena conservation of momentum de hot po ane ko hazik central mass ki concept de hot tu ni na sige points de lai tini hong oi ko hong oi dabni na aina kamaina lawsan sige habda ngasai gi central mass sidai lo olage waina ngasai asom side ki se ka the 50 into adum 50 plus 10 hai ta 50 into 10 plus 0.5 into 10 or the h mind or 50.5 da actually ngau gadra na among ngau da na id am samjani ngai 50.5 into 10 di amka 55 kind ga hening e direct adum ado no ngau gadra okay 50 into 10 plus 0.5 plus 0.5 into 10 divided by 50.5. This is the center of mass. And then all these are negative from side negative negative negative. Now, sigi positive from the layer must be positive lower wall. Do I see diagram in the negative lower gable. Haziz zikti we have magi position C some 10 plus x or on a minus 50 arga some 10 plus x or a to kang debaka. Amazina kaino habda minus Korea. Amazidi kaino 0.5 sigidi kaino position 0 or money kaino di to madi si ogram ne. Can I guys divided by k 50.5. 10 plus x amazina minus 0.5 into 0 chumrasan hai chumika margin 10 salakpa the dcm 50.5 50.5 kakraba on a minus low in kakreka on a cz kai tare 500 plus cz kai no 500 lantra 500 plus 5 chumra chumika is equal to 500 hierarchy sidum plus lo wala ge minus ka on 50x this is na kay dum cd 0 sa crane is this it implies kay tare 500 ka kre ka x is equal to kay no the 5 by 50 which is equal to 1 by 10 yarba
0.1
this is 0.1 pange aduna c 0.1 pange si dai di 10 plus 0.1 di kay no 10.1 am ta dra smai holo ju yadra yai ko
Yes, sir.
Oi, sir.
So left hand side ki se x ani mak 10 oi se kai gino di ngasai di 10 de lapam mi di originally di moi je same position de lai du di si 10 nga tani haujik na amana 0 sakre amana 10 plus x lai ana si zino ile plus ta thamas ya aina position di wall som de lai pen wall ji asom ram di plus ram de ne so aduni ko ana noi different perspective to uba ngam ga dabne sina di hena lai ga doine aina ngasai aham hot ki trom do the prithvi rasna sir conservation of linear momentum pan be abra have the yai external force later yai have gain ng pan be one ko so anyway let's move on gyan loin ta hora ba sige
Tahor
alright ko okay fine so me and over yaw di aure ko ngasi se anova ani di aure ani zi no kano to has class di kano to ro ko introduce to ro at the because we'll only talk about the subject ko anyway fine vector product of two vectors. So vector product ikhangi ko sir na vector already takrabani across b the vector product we have the ab sin theta lakani ko so vectors abc are such that this and this then the vector parallel to a is cc khangbra ma'am khangbro khang the bro no response no either and respond to do talk no khang dragadi sir khang do man de khangni hagadi ta khangni adu hairoba pungju hogi ba khangau diang it's already 9:24 yes sunanda haro kai khangye ba ko audi kai ta dena
C is that
C is that then the vector parallel to A is an hero. Okay, fine. Now see the IC no A dot B Z 0 tai have the A ga B ga Z perpendicular in A and A ga C ga Z perpendicular in A ga B ga Z perpendicular in A. This is vector A. Let's say this is vector A and let's say this is vector B and let's say this is vector C A ga B ga perpendicular or dot product 0 A ga C ga perpendicular or dot product 0 kain is line kain then the vector parallel to A the parallel is B cross C to zup adam kedoba parallel or any so option C tar मैम C की ज्ञान था उबरा okay fine sir checking atang post hoge ka aduga 1 second recording atang post hoge so pause and stop alter P pause ka all right so C gi in the ko yare ka option number C is the right answer now question C gi the gyan ta gadre next question je 11 A and B are two vectors and theta is the angle between them if A cross B is this then the value of theta is C singam gadra ma'am
try to sir
try toro aduga sat hairo option C gi ka 12 sisu dum try toro 13 14 pulap try to be actually am la question ji try to noro question number 11 sorry
sir 11 to 60 down
60 degree type
60
60 type ka okay fine question number 12 thi what about 12
D male
D taba male ka okay fine now ying ji ka kai ta yings chi kitang shift out the ya kai mani chwa shift out ka di mana kanjan gadra khandi kanjalani shoidam ki so sing atang mangal lage na fine all right yeah ka so question number C 2007 की question सीधा is can and the two vectors theta is the angle between them blah 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 other this is the cross product nina AB sin theta hayani aduga maji magnitude habanina my normal vector do yaura ko magnitude 1 unit vector nina ko aduga C sidana √3 haga AB cos theta audi AB ka cre sin by cos tan theta na √3 hoga 60 degree tar if the angle between two vectors A and B is theta, the value of the product of B cross A dot A is an B cross A is perpendicular to A any two vectors which are perpendicular Z dot product log is 0 tie option number D ka. Gyan tao bro jikita yam tumalaba. Option number A ta D Kingston ka yin option number A hai zi kai deno A di ani mam ta dana third super 0 na A hai za A cross B C ta again ngasai du chamana is the sin by cos 10 of the 60 degree then the value of A plus B of the 60 degree the kind of the A square plus B square plus twice AB kaidoba cos 60 degree. So cos 60 di half nina 1 tarne on AB tarne on option number A. Yes, she's last case option number A tai ko. Ma'am haziki tu gyan ta hobra.
Tayo, sir.
Tayo, sir.
She's
Tayo,
option
sir.
number A. Okay, fine. Adune so hot video tak lang dan to we ko. Okay, fine. Now, angular velocity and its relation with linear velocity, then torque and angular momentum and high. She said, "Idea na physical class. I'm talking about part your interest. Kay the torque angular momentum was actually online the 3D. She na tapo di faba. Equilibrium rigid body moment of inertia. Okay, I bet you one formula. I'm copy get do ga. Sige formula ga kang lao na ko. Next class tong na. Kuina rotational. Kaidoba analog haji khangi ko na noina keno da tambo do bio da kai analogous organ homologous organ na amatamra tammi ko ana rotational analog of kaidoba translational physical quantities hai ta ko na translational physical quantities hai ni ko pq hai ja. So some rotational analog ta jiki kaidoba ina let's say angular displacement and laiteni angular displacement si kai kana gi no rotational analog of linear displacement natraga chumna gi displacement chumna displacement the same with linear displacement ko eba ko adwain to udana rotational analog ta angular velocity en lay ko my symbol na sisini omega ni aduga somdana linear velocity my symbol na v oi ko angular displacement gi symbol si theta oi how much angle ko line to na si dana s oi displacement je ko adwain to dana acceleration ang hapage ko na angular moment ihe ay ka crane sorry it's angular and then linear dana kai angular momentum is kind of L name ko. Again, this is vector, this is vector, this is vector, this is vector ni. Ko vector nga tani si loy mo ko. Vector ni. Ko audagi linear momentum na kay no p vector. Yare ko. Dan lay din vector oy ko. Sina L vector oy din. Audadi mathang da atopa kay mayamam lay let's say mass hag. Sorry, so from the mass, I don't know from the mass. From the translational inertia or moment of inertia hierarchy. Inertia is a moment of inertia. Moment of inertia I scalar ni. Some saitana translational inertia. Translational inertia. Now translational inertia is symbol si my aduga mazi atopa maming zi mass ko ika. Translational inertia is mass ni. Dumain to duna atopa kay lay from the torque lay TORQUE torque si tau duni and it's a vector. So main to duna som dana kay force lay duni ka force and it is F which is a vector. Yay ka. So atopa di kay sub thidok pa laitre angular momentum acceleration angular acceleration na mawala me ka. Angular acceleration my symbol si alpha ni it's a vector. Aduga som saitana linear acceleration and my symbol na A ni and it's a vector ka sumain lay gito ni yare ko ma'am sige siya Now, CGC aina noida kanganingba amana kaino habita magi relationship ma'am do kanganinge bako relationship kaido sat long pi ge na CC tang asum san san be yani yare ko okay fine so magi relationship kaiji kai lei ha matam da ka khoina theta and s ka mai marak lei relationship sidi ishoka kaino taude ka theta and s sidi thuidongna leite magi di ka L is equal to R theta kind of again that's not very important. Now V ka omega gi di koina kai relationship lay have the V vector is equal to omega cross R oi kai the way oi in a don't worry I dum kai lakani ka I'll explain everything don't worry matang the L vector have a C kai ga manai ha matam da R cross P ga manai aduga I have a C MR square ga manai aduga talk tau have a C R cross F ga manai aduga alpha have a C kadova angular acceleration ne ko auna madi R cross E di haina de ko angular acceleration se ko duna we have the acceleration across A I gadra omega cross R ka yes omega cross R le ni acceleration sida t ne yanzilaga di A is equal to oh yeah dum sisimala le ka alpha imota sumaina ne harage ka A vector is equal to harga alpha cross R sumaina yare ko isa so C sida ila ni ko last ki C is related wave so C is for na kangadamni ko formula si fan kangadamni and formula si kai de line no ko lino adu to siam tine important wave ko auna C class C before we wind up let us watch a video makag yeng C ko adu galoshan zeba ko I'll just open YouTube and then we'll watch a small video 1 second ko
No one told me college would be so damn. Just good grammar. It's great. Can it help? Okay, hi. Brett. Two girls here.
Yeah, Brett, you can.
Demo on moment of inertia.
Sure.
Play post. Okay, fine. Sir, na screen can to easy screen just share to easy tabra. Talk ra fazina.
To
What
sir.
is that?
So because sounds dum talk ra.
To
ika. Okay, fine. Am tanga yeng no ka. I'll play with one. Eka, yung sis.
The demo on moment of inertia. What do you think about that? So, which of you two girls is stronger? Me. Are you sure? Okay. Well, we're gonna do a thing. I have put these together already. Okay, here I have two sticks. This one's got two juice boxes on the end of the stick. Same two juice boxes in the middle. So, can you girls tell me which one do you think is heavier? Why do you think this one's heavier?
Okay, fine. So, nui ko kan tong na ro hadi azikine stick ani da weight ani yawe ba ko so mathak kisne na heavy oi gadra makha kisne na heavy oi gadra haina ro ma'am response am lagti se kayino response am lagti se hello kayino am lagti response Lakshmi tabra Sunanda tabra
Oh, tare sir.
okay fine
kita.
Nahak chapur.
Prithviraj tabra Prithivira tat krama le ko. Okay, so no hainaroba sigi se mathaki sinen lum gadra makai sinen lum gadra. Ha. Kumak tre muka. Mathaki sinen lum diro makai sinen lum diro.
Makhagisine sir.
Makhagi sinen lum ni ba Lakshmi gi ko. Atai di atai Sinthoi, Sunanda, Kingshan, Asterisk, Eden, Nikhil. Mathaka makhagi se kam lum dino.
Mathak kaise makhag?
Sunanda na mathaki sinen lum ni ba ko. Aduga Lakshmi ga kana gano makhagi sinen lum ni ja. Sinthoi di kam lum ni Sinthoi hero. Esther hero. Sinthoi. Eden na makhane hen lum ni ba ko. Lakshmi makhane hen lum ni ba. Adagi keno na Sunanda na mathak ne lum ni ba ko. Okay. So Sinthoi ji yaudi yauri kumak tre che ta dravzara. Sinthoi sir fazina ta dre chappe ba ko. Okay. Anyway, Prithivira se tat kre ba ko. Noi net kanungai na da mi yaur male. Ani ji lum chap mana ni kamai na kedo bai mathaki sin lum doino kedo bai makhagi sin lum doino kai no same mass na tro. Road ani mak chap mana mass ani mak chap mana ni duna chingjan gera laptop kera they have the same mass and weight the mz ne ba. M zu mana z di constant ne. Have the expression due to gravity kashuk sida ho ngoi ba so an ka kenal ne. Ano z zu the mg do z di z laser m du chap mana re mass chap mana dro. Total mass is chap mana dro ba. Adi kai do bogi mathaki ne lum doino or makhai ne lum do chap mana ni. Gyan dai ta de.
Tai sir.
Tai ko mass chap mana ni ko amana kashu he lo amana kashu tar.
You think so? What about you? They're the same. Why do you think they're the same? They're both the stick and they both have two juice boxes. So they're both the same stuff, right? So you should think the same. Yes. So what we're gonna do is we're gonna play a game to see who's stronger. And what you're gonna do is you're gonna take the stick and hold the middle, and we're gonna see you're gonna turn it back and forth 10 times, quick as you can with just one hand. Does that sound like a fun game? Okay, you hold that one in the middle, one hand. Hold that one in the middle, one hand. Okay, and you're gonna one-handed, and it's gonna be 10 times this way. 1, 2, 3, 4, like that. On your mark, get set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She won. I didn't do 10. No, you didn't do 10. You didn't do as fast. I was. Okay, now switch. We're gonna hold the middle. Okay, let's do it again. Your mark, get set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which one's easier?
Okay, fine. Yare ko. So, sisina haining izi kaino hai matamda. Aziki video duna ko. Tangning izi moment of inertia se. Sigi matang na newa sir na haining izi ko. So, munataro aduna ko everyone ko listen carefully. Sir na ne haining izi. Okay, fine. Haziki dunoi keno ta hobra. Gyan ta hobra. Gyan ta hobra ziki dam. Okay, fine. So now you go. Motion, there are two types of motion. Translational motion, rotational motion. So raise the layer of body, ina motion the pura the external force the ka. So adumain to dana raise the layer of body, translational motion the pura the torque the car Now, aina force panam p batargasu mass to niam. For example, aina mass macham na igi box macham the move to chat kaneva. Aina asi wall the panam kana push to chat loeva. Kaygino the walls gi kayam chawi inertia yam chaweva. And inertia is the mass the measure to translational motion given. Yan taika. So mind to the rotation the mass the katang depend to deva. Kayda depend to rotation the my distance or distribution of mass will depend to adu dubu moment of inertia ko gyan dai ta de tai ko aduna mana sumaina haiba matam da mass to magi axis of rotation yam naksala kanda my moment of inertia p ona yam line rotate to ngam ne ba laptho kanda di my moment of inertia chawrakani ba kaino di moment of inertia habisi kaino habada, this is the kaine inertia of rotation ever, rotational inertia never. Mass in a translational inertia. Gyan tai ko ja. Gyan ta ngambra, lausan mangambra. Inertia of translational motion is measured in terms of mass. Mass saurigai translational motion si change to one race the labor nang velocity move to the one year and velocity no salambado nang yankat and board turn with the 1 year mass am saurigai inertia am saurigai adu translational inertia ne so mind to rotational motion the move to ho grena lapagadi amuk khanglep lepan with the 1 year ngam moeva then race the muk khang buzung 1 year ngam moeva yam 1 year kai you know have the inertia translational inertia am chaweeba adu sorry rotational inertia am chaweeba adugi rotational inertia dubu khina moment of inertia ka weba ko auna adu gumba sing duni next class sir na ko kena tawning izi naina ning izi ai so I have already shared the screen now kai gino talk to say yare ka adugi ni aduna moment of inertia de kai chakra moment of inertia I is kai know my symbol my relation is mr square ka mass ka suma related hoy we'll do all this late next class we'll discuss all this in the next class so ngasi it's already 9:48 so we'll call off ngasi gidi sitaw ina let's call off for the day. Good night everyone.
Good night, sir.
Good night, sir. Thank you, sir.
Yeah, okay. Thank you for the class. Good night.